Okay, what I'm discussing today is the same notes that we had from the lesson before, and we're still going to look at this example. Sharon wants to find out how much money she will have in her savings account after 10 weeks. She has $20 now and will earn $10 an hour babysitting for the next 10 weeks. If she works 15 hours a week, how much money will she have after 10 weeks? All right. So this is $10 an hour at 15 hours a week. So X stands for the weeks, and this is the rule. Now, we created this rule the other day. We also did this chart the other day where we start at 0, and she had $20 to begin with, and then each week that's $150. So this is where she ends up after 10 weeks. So the answer to the question is $1,520. However, what we are doing now is, and I'm going to skip the graph, because what I want to do now is I want to talk to you about set notation. So we have interval notation, which is what we've been doing up to this point, but now we are going to do set notation. So if I look at the domain of that function, the domain goes from 0 to 20. And so I'm going from 0 all the way up to 20, and so therefore, and that is our domain, because at I think it should say 10. Yes, I messed up. I'm sorry about that. It should say 10. That's how come I was kind of stuttering for a minute. All right, this should say 10 right here. I forgot how many weeks we were doing it for. So these numbers should also be 10. When I do set notation, what I'm doing is I'm writing it X such that this is true. And so, and this would say 10 is less than or equal to, X is less than or equal to 1,520. All right, so up here, the domain is going all the way from 0 to 10. And this right here is interval notation. This is set notation. This little line means such that, and we're putting it with a this type of bracket to denote that it's a set. So we're saying X such that this scenario is true. So X is going from 0 weeks to 10 weeks, and we put X in the middle, and we always use the smallest number to the biggest number, and we use less than symbols. So 0 is less than or equal to X is less than or equal to 10, gives you those weeks between 0 and 10. Now the qualifier here is that these are integers and there won't be any fractions or decimals. Now, and the qualifier on this one would be that it's going up $150 each week. So it's not every number between 10 and 1,520. But, so again, this is interval notation on the left, which is what we've been doing. So that's interval notation, showing the interval where this is happening. And the range, which is your Y, and I wrote X such that, Y such that, sorry about all that, y'all. Y such that 10 is less than or equal to Y is less than or equal to 1,520. And you're just saying Y falls between 10 and 1,520. Mathematics just always has to come up with another way to say the same thing. So these two things are saying the same thing in another way. Okay, and when we do intervals of increase and decrease, remember this function is increasing all the way from 0 to 10. I do not know where 20 came from in my head when I was doing this, but we're just going up to 10 weeks. So this is increasing all the way from 0 to 10. The whole function, the entire function is increasing. And we say, now remember, when we label for increase, the increase decrease says this is what Y is doing. So Y is increasing here. So this is an increasing function. So Y is increasing, and where at is Y increasing on the x-axis. Well, it's increasing from 0 to 10. That's the interval. This is the set notation. So x such that 0 is less than or equal to x is less than or equal to 10. All right, this whole thing is positive. It's not negative. And again, it's positive from 0 to 10. So this looks monotonous. It's saying the same thing. X such that 0 is less than or equal to x is less than or equal to 20. All those numbers between 10. All those numbers between 0 and 10 is where this is increasing. And I apologize for writing 20 all over everywhere, y'all. All right, but you get the idea. Okay, now let's look at this one. This is a theory, and I only answered on this video the ones that had set notation. So the others I didn't bother with. They're on the video prior to this one that you can look at on that lesson. All right, so here's our line. Remember, we label our arrows this way. So this one lies between infinity and negative infinity. That's the x, that's the y. This one is negative infinity, infinity. This is the x, that's the y, if I were to label those arrows. Now, the domain stretches from negative infinity all the way to infinity. And so here's your interval notation from negative infinity to infinity. Here is set notation. And I wrote two different ones. You might see x such that x is an element of all real numbers, because if it's going from negative infinity to infinity, it is an element of all real numbers. Or x such that negative infinity is less than x, and I don't use less than or equal to here because we don't ever reach infinity. So because we don't reach it, we leave it as less than. So negative infinity is the smallest one, is less than, x is less than infinity. So you're kind of inserting an x between your two endpoints here, and you're saying x such that negative infinity less than x less than infinity. All right, same thing here. This one is decreasing. This is what's happening. The line is going down. That's the y. That's what's happening to the y. Here's the interval notation, negative infinity to infinity. Here is the set notation. X such that negative infinity is less than x is less than infinity. All right, and this one is positive. Remember, all this area up here is positive on the graph. All this area down here is negative. And our separator, I guess you could say, on the graph itself is this point right here. It separates. Even though these x values over here will be positive, 2.5 to infinity, that's actually where the graph is negative. So from 2.5 to infinity, y is negative. And we write that this way, and then we say x such that 2.5 is less than x is less than infinity. Now, I don't use less than equal to here, because at 2.5, that's not negative. 0 is not negative, nor is it positive. It's just a stopping point. So that's the set notation for positive. It is positive all the way from negative infinity to 2.5. So it is positive from negative infinity to 2.5, and we say x such that negative infinity is less than x is less than 2.5. And I only went over the parts of these notes that involved set notation.